Hello and welcome to Simple Circuits. Our learning objective today is that I can identify the components of and describe the motion of charged particles in a simple circuit. Now, I do want to remind us that we are going to have some stop and think about it during the video as we move through this lesson today. You do need to actually stop the video and to complete the task on the paper before moving on in the video. Do not wait till the end of the video to complete all of these tasks. Please do make sure that you stop, use the knowledge chunk that you've just gained to complete your stop and think about it task. Okay, here we go. Simple circuits. A simple circuit must contain three components: a source of electric energy, an electric device, and an electric conductor. In this case, the simple circuit that we are currently looking at, we have our electric device right here, which is a light. It could be a cell phone. It could be a buzzer or something that we use to create a simple circuit. Anything that activates or turns on when we have a circuit is that electric device. We have our electric conductor, which is our wire. It's green on this side, and our red wire on this side as our electric conductor. And last but not least, we have our source of electric energy. In this case, it is our battery. So we need to review some vocabulary. So we got this word conductor again. We've learned that last unit. So let's review it again. Conductor is a material that a charged particle can move through easily. Do you remember back from our Coca-Cola lab on page 212? You want to go back and see what kind of charged particles move through those conductors. So here's one of our stop and think about it. So what I want you to do at this moment, I want you on your paper to identify each circuit component that you have there. I want you to identify the electric energy source in blue. I want you to identify the electric device in orange and your electric conductor in red. So find some color pencils or a marker and stop the video to identify these pieces on your notes. Okay, well, hopefully you stopped and completed this piece. We're going to move on to our next chunk of notes. A closed circuit. So I was watching a video to introduce for this today, and it was referring to a circuit is a circle. That is absolutely right. It needs to be a complete circle to be a closed or a complete circuit. So let's look at what we've got here. A closed circuit is when a circuit is complete, like our circle, and electric energy, which is those charged particles, can flow through it without interruption. So let's take a look at this quick video from FET. We have our closed system. We have our electric conductor. Those are our wires. We have our electric device, which is our light bulb. And we have our electric energy source, which in this case is our battery. Okay, here we go. Moving on. How can we turn on and off circuits? How does that work? Sometimes the light bulb's off. Sometimes the light bulb's on. How does that happen? That happens through switches. Switches right here, these little black pieces right here. Switches create breaks in the conductor. They make breaks in that circle. We do not have a complete circle. Over here, our light bulb is on. We have our complete circle. We have a break in our circle. So this is creating what is called an open circuit. An open circuit is created when the circuit is not complete and no electric energy, those charged particles, cannot flow through the circuit. Here's our next stop and think about it. Draw and label a closed and an open circuit on your notes page. Now you do have to figure out which one is closed and open using our definitions. Include a quick description for each circuit. So how do we know when we have a closed circuit and how do we know when we have an open circuit? Again, make sure you pause this video right now, complete your stop and think about it, and come back when you're ready. All right, so hopefully you created your circuits, open and closed, and